So let's imagine a ceiling fan. So we've got a ceiling fan here. And let's say that the ceiling fan is rotating at 42.0 RPM. So that's revolutions per minute. And when you turn off the ceiling fan, it has an acceleration, an angular acceleration of minus 0.143 radian per second squared. So that's how quickly it's slowing down. So I want to know a couple of things. How long does it take to stop? And how many rotations does it do as it's stopping? So let's go ahead and answer those questions. Okay. Well, first issue is we had radian per second squared and revolutions per minute. So let's convert the 42.0 revolutions per minute, so that's RPM. Okay, we want that to be radians per second. Okay, so we know that a revolution is 2 pi radians. So there's 2 pi radians in one revolution. And then we know that a minute is the same as 60 seconds. So 42 revolutions per minute comes out to be 4.40 radians per second. All right, now, there's our unit conversion. So the very first thing we said was, how long does it take to stop? So we know that V equals V naught plus AT. That sort of should be ingrained in you from chapter 2. So we just rewrite this with angular variables. So that's going to be omega naught plus alpha t. And notice we're not doing anything different. We're just substituting Greek letters for the Roman letters. And so when it stopped, it's not rotating, so the final is going to be 0. So that means t equals minus omega naught over alpha. So that's going to be minus 4.4 radians per second divided by 0.143 radian per second squared. And so that means it takes 30.8 seconds to stop. Okay, next question. How far did it go to stop? Well, we know that x is x naught plus v naught t plus 1/2 at squared. Again, this should be ingrained in you. So we just substitute for angular variables. So theta is theta naught plus omega naught t plus 1/2 alpha t squared. I can put my origin and say alpha naught is theta naught 0 when we start. Now, we know what omega naught is. Omega naught is 4.4 radians per second. We know alpha. We now know t. So I could just plug in here, or I could use my t equals minus omega naught over alpha and plug that in. And if I do, I get that after a couple steps of algebra, theta equals minus omega naught squared over 2 alpha. Now, what would be the advantage of that? Well, I could plug in here the number for t that I just had, or I could just go straight to here and plug things in. It doesn't really matter. You get the same answer. Either way, if you plug in the numbers, you're going to get 67.7 radians. Okay, so that's going to be the theta. Okay, they both give you the same answer. It doesn't really matter. So that's the angle through which the ceiling fan turned. So we had the ceiling fan right here, okay, and it went through an angle here, and the total angle was 67.7 radians. Okay, now we know that there's 2 pi radians equals 1 revolution. So I asked, how many times does it go around? So if I want to know how many times does it go around, it's 67.7 radians divided by 2 pi. Radians per revolution, and so that gives me 10.8 revolutions. So that means it went around 10 times, almost 11 times. So 10.8 times it went around. Okay, so there's my answer right there. Now, the other question that'd be interesting to ask is, as this thing is going around, how far did the tip move? Okay, so if you knew, for example, if you knew for your ceiling fan here, should make it more. Should try to make this more symmetric. If we know that each blade sticks out a distance of 75 centimeters, and I want to know how far distance did the tip go, well, the distance around is going to be r times theta. So that would be 0.75 meters times the 67.7 radians. And so that means that the tip would go around a total distance of 50.8 meters. All right, so this is our first example problem. It's just a ceiling fan rotating. And everybody's seen ceiling fans rotating. So this is the physics, the kinematics of that motion.